Good morning students. In this video we will discuss one example for second normal form. They have given a relation R which consists of 8 attributes A to H, and they have given set of FDs, and even they have given the candidate key, and they are asking whether it is in 2NF or not. Usually sometimes they may give the candidate key also. If they does not give the candidate key, we have to identify what is the candidate key for the relation. Okay. Now once they have given the candidate key, it is very easy for us to identify what are the key attributes. What are the key attributes? The attributes which are there in the candidate key are called as the key attributes. So A, B, D, E, F are there in the key attributes. A is there, D is there, B, E, F are the attributes belongs to key attributes. The non-key attributes are, the non-key attributes are the attributes which are there in the original relation but not there in the key attributes list. So I can say that they are C because AB is there, C is not there, EF is there, GH is not there. So these are the set of key attributes and these are the set of non-key attributes. Now we need to check whether any partial dependency is there in the given FDs. If there is a partial dependency, I can say that the relation is not in 2NF. If there are no partial dependencies, I can say that the relation is in 2NF. For making it simple, we will decompose the FDs such a way that the right hand side will consist of only one attribute. If you see that we have FD CH determines G and we have an FD A determines BC, I will decompose it as A determines B and A determines C. Now we have B determines C of H, so I will decompose it into B determines C, B determines F, B determines H. Then you have E determines A and F determines EZ is there. I am decomposing it as F determines E and F determines G. So the original FDs I have decomposed into these FDs such a way that the right hand side will have only single attributes. Okay. Now if you see that, come to this first FD. CH determines G, where G is a non-key attribute. And what is the partial dependency? If you have not gone through this earlier video, let me discuss what is a partial dependency. If you have an attribute ABC in the relation R and AB is a candidate key, there is an FD called B determines C. If AB is the candidate key, prime attributes are A, B, C is the non-prime attribute. So C is a non-prime attribute is depending on partial of the candidate key, because AB is the key candidate key, then B is the partial of the candidate key. So I can say that a non-key attribute is depending on partial of the candidate key. Okay, then I can say that it is a partial dependency. Okay, now if you see that left hand side is not a part of the candidate key. What is the candidate key? Either AD or BD or ED or FD. CH is not part of the candidate key. Okay, because C is not there in the candidate key list or the key attributes list. So I can say that this is not the partial dependency. However, it is a transitive dependencies. If you does not know what is a transitive dependency, you don't worry. We will discuss in 3NF. Okay, it is not the partial dependency. Now A determines B. Lot of people will confuse and says that this is partial dependency. Why? They say that AD is the candidate key, so left hand side I have a part of the candidate key. They will say that it is partial dependency. No, it is not a partial dependency. Why? The right hand side should be a non-key attribute. B is a key attribute, B is not a non-key attribute. So I no need to check what is there in the left hand side, and I can say that it is not a partial dependency. Now A determines C. If you see this one, will be interesting. Now if you see that C is a non-key attribute, the first condition is satisfied. The RHS is having a non-key attribute. The LHS is having the part of the candidate key called AD. AD is the candidate key. Part of the AD is A, which is there in the left hand side. So I can say this is a partial dependency. As there is a partial dependency, I can straight away say that it is not a 2NF. Okay? Is it clear? But for a better understanding, I will find out which are partial dependencies or which are not. B determines C is there. C is a non-prime attribute and B is a part of the candidate key called BD. So I can say that it is a partial dependency. Now B determines F. F is a prime attribute. So I can say that it is not a partial dependency. B determines H. H is a non-prime attribute. B is a part of the candidate key. So I can say that it is a partial dependency. Now E determines A is there. A is a prime attribute. So I can say that it is not a partial dependency. F determines E is there. E is a prime attribute. So I can say that it is not a partial dependency. F determines G is there. G is a non-key attribute and F is a part of the FD. So I can say that as FD is a candidate key, I can say that it is a partial dependency. So how many partial dependencies you have? 4 partial dependencies you have. If you have one partial dependency, then you can say that it is not a 2NF. As you have 4 partial dependencies are there, then you can say that it is not a 2NF. In a GATE exam or any competitive exam, if you find one partial dependency, you can stop there and you can say that it is not in the second normal form. I hope with this example, how to check whether the relation is in 2NF or not. If you does not understand with this example, don't worry. I will take few more examples such a way that you will understand the concepts in a better way. Thank you so much.